Okay, let us see another question here. A boy is running at 4 meters per second on a bearing of 40 degrees. 40 degrees. And the girl appears to be moving at 60 meters per second on a bearing of north 50 towards the west. Find the true velocity of the girl. So here in our solution, they are telling us that the velocity of the boy, let us first consider the boy. So the boy, this is going to be his so if that is our compass. That is our compass. So for him is running at, so he's running, but they're giving us a bearing of 40 degrees. So this is our north line, and now this is going to be the speed at which he is running. So we need always the velocity of this in a vector form. So we are going to resolve this. Now we shall resolve it in this form and then going in this form. Why am I resolving going up here? Because my angle is with this. If it was here, it would be easier for me to go like this and then like this. But because my angle is here, that's why then I go like that. So here, because this is adjacent, it's going to be 4 cos 40 degrees. Adjacent goes with cos. Then this is opposite, so it will be 4 sine 40 degrees. And so there, the velocity of the ball is going to be, you see, it's going in a positive, so we have 4, the x component of this velocity. So it's going to be 4 sine 40 degrees, and so this one is going up, so 4 cos 40 degrees. That's going to be the velocity of the boy. So then they are telling us that a girl appears. Whenever you hear the word appear, it means that that's the relative velocity. So a girl appears to be moving. So that means that the girl appears to be moving. So now the velocity of the girl relative to that of the boy. So the girl appears to be, in simple terms, the velocity of the girl relative to that of the boy. That's what they are giving us. So they are giving us this as 6 meters per second on. Now they are giving, whenever they give you the magnitude of the velocity, they will always give you the direction. So let us come and we also give this. So if I'm to draw my compass there, this is going to be north. This is our north. We are going off 50 degrees towards the west. This is the west. So that's how it will be. So this one, we are going off 50 degrees. So this one is 6 meters per second. So to resolve that velocity, you see where the angle is, I move like this, then like this. So I go in that direction, then after I move that way. So you see this one is going to be now, it's adjacent 6 cos 50 degrees. Then this is opposite, so it will be 6 sine 50 degrees. So implying that now this one is going to be given as d VB is going to be given as the x component, so it's going inside, so it's in the negative, so negative 6 sine 50 degrees. Then this one is going up 6 cos 50 degrees. As simple as that. So we have that, we have that. So what the true velocity of the gap. But you know, from the d VB is equal to the velocity of the girl minus the velocity of the ball. So if you have the velocity of the girl relative to that of the boy, is equal to the velocity of the girl minus the velocity of the boy. We have this, so we can easily get that. I think we can say that our velocity of the girl is going to be, when you bring this beside, relative to that of the boy, and plus velocity of the boy. When you take this, that side. So now our velocity of the girl is going to be, the substitute this one is negative 6. Then the velocity of the boy towards 4. So from there, you give your answers for the small places. This is negative 2.0251. Then this one, we add this plus this, we shall get this, then this plus this gave us that. So this one is really not 6.920,209. These are in meters per second. Then we get the magnitude. So I think you can see if we try to plot this, that now our x is in this direction, then our y for it, it is a positive. Okay, so that our x is negative, so do like this, it's the negative, and our y already is a positive. So negative, this is shown as negative, so 2.0251, yet the y is positive 6.9209, and then this is going to be my velocity of the gun. So of course, if you want to give direction, you always give it to the horizontal. Now, note, when we are in forces, our angles are given to the horizontal, but when we are in the bearings and the things of relative velocities, our angle is given. It's always described based on the north line. So that's why I'm putting my alpha here, not here, because when we are in forces, we put it here because we want it to the horizontal, but here I want it to the vertical. Okay, so from there I can see that my velocity of the gun is going to be the square root of 2.0 squared, this one, then plus the whole squared. So my velocity of the gun is going to be would be 7.2111 meters per second. So remember, always the velocity. Now this is the magnitude of the velocity. So you need to be also the direction, because always velocity has magnitude and direction, because it's a vector quantity. So then the angle, so our alpha is going to be tan inverse. Our opposite, this is going to be the opposite of adjacent. So our opposite is this 2.0251 over 6.9209. So our alpha there is going to be 16.31 degrees. So therefore, velocity of that is 7.211 meters per second in direction of, now we can give this, you see that now, here we are going like this from the north. So in the direction of north, how many degrees? You see we are going this side, north, 16.31 degrees towards the west. Or what you can do, you can give the bars, or you can come and give the bars, and then you give the whole of this from here up to there. And see, you just get this minus 1, 360, minus us. So this will be 3, 4. this. So you either give the hole from here to this, or you will describe that one. It's up to you. Or 3.6 degrees. So you give one, don't put all. So this one was just to show you. So that's it. I wish you well.